I'm going to talk about two books on quantum groups, actually, more specifically. So let me see the first one. It's finite dimensional algebras and quantum groups. It's published by the American Math Society in 2008. Now, so what is this book? It's 759 pages. So let me start with the motivation why we want to, introduce such books. So there are briefly, you can say, three research areas in mathematics. One is called Lie theory. It's a huge area, including Lie algebras, Lie groups, algebraic groups, and their representations, etc., etc. But there is a relatively small area called the representation of finite dimensional algebras. But in the 1970s, this approach was introduced and Gabor established classification of the indecomposable representation of a linking paper. So you think, that's from Lie theory, right? And in terms of positive roots. Then this work has been generalized in the 80s by Katz to, Katz-Moody algebras, etc. So that's, you can see, I just mentioned 7 days, this area touched Lie theory a little bit at the root system level. There's even probably relatively small area, part of the group theory of Cox groups and the holographic algebras. So for these three series, you can all find it in the Lie theory of other books, the algebras, Lie groups, algebraic groups, quantum groups, etc. You can find in many books on this representation series, and even you have these three books on theory of Cox groups. Okay, so they are somewhat relatively independent, but the motivation we start with is actually something like in the late 80s, when you just mentioned one thing interesting, Frank Marshall Scott, discovered a class of finite dimensional positive algebras. Now this is the comments, Cross-Bruno actually is the leader in the representation theory of finite dimensional algebras. So he made the following comments. It seems surprising that this class of algebras has not been studied before by mathematicians devoted to research. Because CPS, Frank Marshall Scott, they're actually working the representation theory of algebraic groups. Nothing to do with the representation of finite dimensional algebra. But they discovered this, they find some phenomenon in that part of representation theory, then they get a new class of algebra called the positive algebras. So, like Cross-Bruno mentioned, even when Scott started propagating positive algebra, it took him some time to find some new theory, resonance, etc. So that's quite an interesting comment. But interestingly, of course, Ringo was impressed with this discovery of new algebra, a class of new algebra. But a few years later, Ringo himself introduced the notion of so-called Ringo Hall algebras. Basically, originally you have Hall algebra, but Ringo modified the original definition that new type of algebras, and proved that they are similar to the first part of the corresponding quantum groups. So that means the other way around, you did, right? You got kind of a new algebra, which is coming from representation theory of finite dimensional algebras. And this kind of algebra have a direct connection with the quantum groups, with the Lie theory. So that's what our motivation. We went to so many conferences, both areas, and we decided actually a long time ago we thought we should have a book. It took a too long time to complete. So our book started with basically 5 parts. We start with the chapter 0, which says getting started. So what are we getting started? We just try to, summarize, what I described before. We start with generalize the column matrix. I have the definition for the column matrix. Then associated to C, there are 3 realizations you just mentioned in the chapter 0, rough realization. For example, I can give you one example like A is C is this matrix, for example, C, 2, minus 1, minus 1, 2, minus 1, minus 1. It's this. Because this is the carbon matrix of type A, then one type of realization you can encode such a carbon matrix by so-called graph like this. 3 vertices and 2 edges, something like that. So this is actually the representation theory of algebra, so they like that. Because if you put some errors here, like this, you get a quiver, then you can talk about representations of these graphs. Okay? Now, the loop datum realization, that's completely related to this theory. It's a loop system. We have the column matrix, we have loop system. And well, in this case, of course, you can talk about loop system like for 1, 2, 3. Okay? That's a simple root. Then you can look at alpha 1 plus alpha 2 and alpha 2 plus alpha 3. The last one will be alpha 1 plus alpha 2 plus alpha 3. And more generally, you can easily construct this inside the Euclidean space, like this kind of roots. And similarly, you can modify this matrix to get the Coxeter matrix. Then you can define the Coxeter group and associate with the Hecke algebras. Okay, so that's what we start with. Then each realization develops a theory in the following 3 parts. Part 1, quivers and their representation, so which contains 3 chapters. We talk about quivers like this and their representation, classification, Gabriel theorem, and of course we use a relatively new method we use for various morphism to discuss the non-supervised case. Part 2, some quantized algebra that's more or less corresponding to the loop datum. You get to the universal developing algebra, then you get to the quantum version of the universal developing algebra. So, part 3, we mainly talk about the Coxeter groups and Hecke algebra representations. So these 3 parts corresponding to the 3 theory I just mentioned. So in some sense, the book is, someone say it is 3 books in 1, 3 books in 1. Then, these theories actually, they merge eventually together in the next 2 parts. So I mentioned the part 1, that's the Riemann-Hall algebra, so I just mentioned the Riemann invented in the Hall algebra, and from representations for one-dimensional algebra, then prove this Hall algebra actually the plus minus part of the quantity. So that's why I say the realization for the plus minus part, which takes 2 chapters to complete. And also, you know, the part 1, part 3, how they connect with each other. You look at a realization for quantity GRE. In that case, we use basically symmetric groups, Coxeter group, and then move on to some Schur algebra. Then from there, we can construct the entire quantum GRE through this kind of finite-dimensional algebra. So they merge eventually in these 2 parts, which will tell you different theory eventually can construct the same objects. Okay? So, comments from the reviewer. So I just mentioned briefly some comments from the Britain American Society. It's a 8 to 9 page long review, and the review concluded that this book is a welcome addition to the literature in this subject. The book should be of particular value to graduate students because we address the seriously in the exercise to graduate students and to apply the broad background knowledge needed to become a successful researcher in this part of the So this review, when we see that review, of course, we feel very happy. And there's another review from Smith. While this book is somewhat more advanced, then would be appropriate for typical introductory graduate course. It should be proved to be better with reference researchers in the future. Okay. So for these reviewers, well, after the book published, actually, the feedback was pretty good, I think. When you come into conferences and people talking about the books, you feel quite happy. Okay? And I just want to, because we have quite a few Russian friends here, so I want to mention one feedback. They're from Russia, you see. So you probably know this professor or associate at Zoom. Well, that's just the email. They couldn't order the book online, use credit card, and some complication in Russia, so they asked me to send the electronic version. Then I said, that's probably impossible to send you the electronic version, but I can send you a hard copy. So I just send a hard copy, just to satisfy them. All right, so this is the first book. So I have used 10 minutes, so that's good. And how about second book? So let's go back and quickly look at the first book, the contents. You see, I have part 5. This is for about content GRA. Okay. But while writing this book, we have a project in trying to understand the situation of the A-finite content GRA. In other words, moving the finite type case to some kind of a tame type, infinite type case. So the second book is the outcome of some research activities. Okay? So this is the very specifically the double Hall algebra approach to A-finite quantum theory. Because in part 5, in the previous book, we namely get to the quantum theory of sure-body duality. That's just for the finite case, GRE, quantum GRE, Hecke algebras, and which is very nice. Then after that work, quite a few people actually, including some very top mathematicians, they did quite a few work trying to generalize the work in the A-finite case. And their method mainly geometric method. Okay? But I feel like the finite type case, or just algebraic methodology, is so nice. But the geometric method is very abstract. It's hard to see what's going on there. So the motivation was we just try to understand their theory algebraically or combinatorially, because this is A-finite type, A-finite symmetric groups, still symmetric groups. So that's the main motivation. So we try to understand other people's work, and we use our own approach. So we introduce so-called double Hall algebra approach. So use this new approach to look at this part of the theory. So it took us probably more than 2 years to get to some work done, in a long paper, which is by that time probably is close to 200 pages. Then we just feel like what we should do. Either break them into 5 papers or 4 papers to submit it to journals, or we just leave it there, get a book version. So it's a bit risky, to try to submit a book to be published. But we did. Interestingly, we were successful. The London Mass Society Lecture Series accepted this long paper. So look at the contents. We have basically 6 chapters, and we have some preliminary versions. Just the background stuff like Hall algebras, etc. Then we have the double Hall algebra approach. This is the main things our new approach introduced. Basically, our motivation is algebraic combinatorial to study this part of the theory. Then we look at A-finite quantum algebra and the sure-body reciprocity. So this is the sure-body view. The classical 100 years ago, people were interested in this part of the theory. But now you look at the infinite version. That's A-finite version, more or less the infinite version. So can we do something for that? Well, we did. We proved some interesting theorem, and we leave a few conjectures we are still working on. I think we have proved recently, a couple of conjectures recently. So quite interestingly. So then we look at A-file quantum Schur algebra. So Schur algebra is Schur introduced over 100 years ago. Then you have the quantum version. Now you have the A-file quantum version. So that's basically infinite dimensional algebra. How do you determine or classify the irreducible representation, etc. So this is chapter 4. Then another type of interesting question was representation and realization problems, because you see the content groups defined by presentation, generators and relations. But the Schur algebra is defined by endomorphism algebra. Okay? So you may ask, this is the concrete algebra, endomorphism algebra. So what is the presentation for this algebra? Okay? On the other hand, the quantum group is defined by generators and relation. Can you get the realization? So the realization means find the basis for the algebra and explicit multiplications between, say, generators and basis elements. So that's a twin question like representation realization associated with the Schur-Bar theory. Okay? Then we have a conjecture actually. Then we prove the conjecture in the classical case, V equals 1 case, not the quantum case. V is a parameter for quantum. Okay? So this just unfortunately, by the time our calculation is too hard, we couldn't get the general case proved. But I think we have done it recently. Of course, we have to change your method and find a way to get it down. So we are pretty lucky for the moment. Okay, so that's all I think. I hope. Oh, I should mention the referees comments, because if you want to publish a book in that series, you need a good referees report, otherwise you won't be accepted. So these are part of the reports. Okay? Part of the report. So, let's start.
Thank you. Any comments or questions?